What does the quadratic formula say? It says that if you have a quadratic equation, ax squared plus bx plus c is equal to 0, that you can calculate the solutions to that quadratic equation in one fell swoop by using the quadratic formula, thus eliminating the need to ever again complete the square to solve a quadratic equation. You still need to complete a square if you're interested in finding out coordinates of a vertex, like in the assignment that I gave you that's due tomorrow. But in terms of solving an equation, you should never even have to use factoring. And this is an important point that I don't know if many of you really appreciate. Some of you struggle with factoring. Factoring is still an important skill outside of solving this equation, these quadratic equations. But as a stopgap measure, which simply means when push comes to shove, if you need to and you don't want to factor, you can always find the solutions using this formula. Even if it is factorable, this is a formula that works all the time for all quadratic equations. Take a look at your work, please, and see if you have any questions you would like me to go over. Yeah.
Could you go over completing the square for the assignment? Because I don't know if I'm doing it right.
I can go over a review of completing the square. I can also tell you that, before I do, that you could always complete the square by cheating, not on this assignment because you have to show your work, right? So there's a way to find out the answer to your question. Because if I gave you this function, I'll just make up a function, this function right here. So I guess I don't make it up, it's already there. If I said to you, to complete the square of that, now be aware here, Thomas, I want to see your work for this assignment. So it's y equals, let's pretend I say complete the square to find out where the vertex is. We can use our graphing calculator to find out the vertex. Right, just let that sink in. You could enter this into your graphing calculator and find the vertex that way, thereby knowing P and Q, right? And A is 7. So you can get the completed square form. So you have to show your work though, right? Okay. So the first step in something like this would be to factor the 7 out of the two terms that have x. So that's what I would have to do first. Then what I'm going to do, and by the way, I don't want to see decimals anywhere on your assignment unless they're precise decimals. Like if it works out to 0.25, you can write 0.25. But 24 divided by 7. You can't write that down. You'd have to write 24 over 7. Now I need to take, I guess I don't need to write this just yet. I need to add something in here, and I'm going to find out what that is by taking 24 over 7, there it is, dividing by 2, and squaring it. Now I don't know how good my calculator is with fractions. Worked out okay, 144 over 49. So I add 144 over 49. I then need to take this number and multiply it by that 144 over 49 to get 144 over 7. 7 will cancel with a 7 in the 49. And that means I subtract 144 over 7. And I'm pretty much done here now. I can write y equals 7. This will be x plus half of 24 over 7, which would be 12 over 7, squared. And then I have to figure out what this is. I think it's negative 81 over 7. Could be wrong though, it wouldn't be the first time. I think I'm wrong. No, I was right. Negative 81 over 7. So, any questions? Any other questions at all from your practice problems? Shannon? 3B? Certainly. So we have to solve this using the quadratic formula, which would be P equals. Notice the quadratic formula is not always x equals. It's whatever letter we're solving for. So P is equal to negative b plus or minus root b squared minus 4ac all over 2a. So P will be equal to, I'm just checking, you said b. Okay. Negative b, which is 12. We need to figure out what b squared minus 4ac is. And again, I'm just pointing out formalities here in terms of working on written response. I know that many of us would probably just go b squared minus 4ac on the calculator, but you need to show that work on a written response. So I would have negative 12 squared plus 4 times negative 9 is that 288? So plus or minus root 288 all over 2a, which is 8. Now don't forget, this was maybe just as important as the quadratic formula. Don't forget that you can only cancel things that are factors. So you can't start canceling anything out of the 12 and the 8 because it's not 12 times everything else. In order for us to see if this is simplifiable, we need to take a little detour here and start talking about the number 288 as a square root. Shannon, when you do these and you simplify these, do you break the 288 up as much as possible and then pull out numbers that occur as pairs? Or do you look for numbers that are perfect squares of 288? Perfect squares. So what two numbers do you want to write here? I'll give you a second to use your calculator. And let me know when you have a couple of numbers. And this is good practice for everybody. Everybody can find the numbers. As a tip here, I would recommend trying some even numbers first. It's not a guarantee that the biggest perfect square will be even, but I'm pretty sure 4 divides in there. So let me explain to you my logic here in finding the numbers. And maybe it will be helpful. I hope it will be helpful. I would go, well, what's 288 divided by 4? And I get 72. Wow. The number is, I just realized right now what the number is. Sometimes what's going to happen is you can just be spinning your wheels trying to find that perfect square that's as big as possible. And that's what's happening here, right? It's not, you keep going further and further. So what I would recommend is, do you have a number that's a perfect square that divides into 288? Bigger the better, but it doesn't have to be. Nine. Okay, so let's do 9. Um, 72? No. I don't know what it is. 32? Okay, so 9 times 32 is 288, so this becomes 3 root 32. And are you fine with that? Okay, now, see, this is the other option, and I think it's actually a good option. Rather than seeking out the biggest perfect square, seek out a perfect square, and then eyeball this radicand that we have left. It's my eyeball, and see if there's another perfect square that divides in. So now we're dealing with a smaller number. So what's a number that divides into 32 that's a perfect square still? Four. So let's do 4. This 3 is there. It's got to be part of our answer. And then you said 4, so this would be root 4 root 8. 4 times 8 is 32. So what does it become now? It becomes 3 times root 4 is 2 root 8. So this becomes 3 times 2 is 6 root 8. And then, when you think you're done, eyeball the radicand again. Is there a number that divides into 8? 4. So we keep going, and now we have 6 times root 4 times root 2. That's 6 times 2, because root 4 is 2, times 2, which gives me 6 times 2 is 12 root 2, and that's it. Okay, so now let's go back to the question. Actually, before I do, I'm just curious because I missed it right away, although I shouldn't have, and I'll explain why in a second. But how many of you saw that the number was 144? Divides 144 goes in twice. So we could have gone root 144, root 2, and that would give us the 12 root 2. The reason I say I should have known that is when I calculated this, I got 144 plus 144. I should have known it was 144 times 2. Anyway, what do we have now? We have p equals 12 plus or minus 12 root 2 over 8. I can factor that 12 out of the numerator and have left 1 plus or minus root 2, and this is over 8. So now what I can do here, everybody, is that 12 and start chipping away at the 12 and the 8. Because, for example, let's say that I want to cancel a 4 out of each of them. I can cancel a 4 out of each because I can write the 12 as 4 times 3. And I can write the 8 as 4 times 2. And then I can see that I have two factors that are common. So I end up with 3 times 1 plus or minus root 2 over 2. I can pretty much, well, guarantee, I may be wrong. I suspect that's not what they have in the back. They probably have 3 plus or minus 3 root 2. Not that it matters, but you can take that 3 and put it back in. I wouldn't. I don't think there's anything to be gained by doing that. Is that okay, Shannon? Okay. Just show you guys a quick little trick here. Do you agree that ultimately what breaking this down boils down to is knowing your times tables? Knowing what pairs of numbers multiply to give 288. So I'm going to show you a way that your calculator can generate pairs of numbers that multiply to give 288. It's very simple Because if one of these numbers, these two numbers have to multiply to give 288, if you call one of the numbers x, the other number is 288 divided by x, isn't it? And I think that's what you're doing, because I saw you doing this and you were going 288 divided by, you were trying different numbers, right? Well, what we can do is this. And I hope that this makes sense to you, so much so that you would understand how to do it on your own. You wouldn't go, well, how does that work again? I can go to my y and put 288 divided by x. Are you with me? If I set up my table now to start at 1 and go up by 1 automatically, then it's going to use x equals 1, and it will take 288 divided by 1, and it will show me those two numbers. It's going to take x equals 2, it's going to divide 288 by 2 and show me those numbers. So I go to my table, here are pairs of numbers that multiply to give 288. You can see right away we hit a perfect square right here. Not by dividing by the perfect square, but by dividing by 2. Does 9 work? Yeah, it does. Does 16 work? Yes, it does, but the biggest one is 144. So there's a way for your calculator to generate those numbers. And that was okay then. Okay. Let's move on. We've got one more topic to cover. And this is dealing with something called the discriminant. We're done the unit today. Tomorrow and Wednesday we review, so your unit exam, as I said, is Thursday. What we're doing today is learning about something called the discriminant, which I've actually taught you a little bit about up to this point in time. The discriminant is a number that tells you something about the solutions to a quadratic equation. As a warm-up here, use the quadratic formula to solve each of the three equations shown below. So the first one has a equals 2, b equals 8, c equals 3. Are you okay with me not writing down the quadratic formula? It's on your formula sheet. And how many of you, by a show of hands, know it already? You just use it so many times. It's x equals negative b, so that would be negative 8, plus or minus the square root of b squared minus 4ac. I'll give everybody a minute to calculate b squared minus 4ac. Let me know if I'm right or wrong there, because I've not been having a great day. Mentally, I'm somewhere else today. 40? Okay, we're good. And then over 2a, which is 4. And root 40, let's see, root 40 is root 4, root 10, which is 2 root 10. X is equal to negative 8 plus or minus 2 root 10 over 4. I can factor a 2 out of the numerator and get x is equal to 2 times negative 4 plus or minus root 10 over 4. That 2 that I factored out cancels with a 2 in the factor pair, 2 times 2, which is the 4. So this simplifies to x equals negative 4 plus or minus root 10 all over 2. We okay there? Yep. Oh, wow. Look at that. Thank you, Lucas. It's actually -8 from the equation. That's not going to affect b squared minus 4ac, but it makes this a positive number, so I've got an error in there. So it's actually 4 plus or minus root 10 over 2. Good catch. What else are we asked to do here? We're asked to relate the solutions to the graph of the corresponding function. So what does this work out to? This is x equals 4 plus root 10 over 2, and x equals 4 minus root 10 over 2. What are those two numbers in relation to the graph of that corresponding function? Well, they're the x-intercepts. So we don't need to do this every time, but I want to do a bit of review here because our exam is this week. Let's see. 4 plus the square root of 10, and I need to divide that now by 2. This is one of them, and then 4 minus the square root of 10. And I need to divide that by 2. So those are your two answers for the solutions to the equation. If we were to graph y equals 2x squared minus 8x, is it plus 3? Thank you. And go zoom 6. Those numbers are going to be the x-intercepts. So if you found the x-intercepts, and I'm not going to do that, but if you found the x-intercepts, those would be those numbers. Okay. All right, let's do this one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which would be 18. I'll give everybody a couple of minutes here to find b squared minus 4ac. I'm getting a discriminant value here of 0. Good, thank you. So if the discriminant, I'm starting to use the letter D for it, is 0, that means there is one solution. And my experience tells me that students want to memorize things in math. Students want to say, oh, I'm going to memorize if the discriminant is 0, there's one solution. That gets confusing in my mind. So I would say to you that your best understanding here is to know that the solutions to the equation will contain something plus or minus the square root of the discriminant. So if the discriminant is 0, it doesn't exist, you're just going to get one answer. And I think that thought process probably takes you 3 seconds, 4 seconds when you get used to it, rather than having to search through the filing cabinets in your mind for that file that tells you the 3 cases to memorize. I think that's more work. So there's one solution. That's the answer. This one. Very, very similar to this one, isn't it? I want to say 32. B squared minus 4ac is 32, which is positive, which means you're going to have something in the quadratic formula plus or minus the square root of a positive number all over some other thing. Well, you're going to get 2 solutions because it's plus or minus. I want to throw something your way. This will not be for everybody, but those of you that glom onto it will understand it and it will be helpful. You know how I always talk about when we solve a quadratic equation, we'd like the first term to be positive? So that's what you always do. If the first term is positive and the last term is negative, there will always be 2 solutions. Because b squared minus 4ac will be a positive number because you're squaring b minus a negative number because c is negative. So whenever you have a positive a and a negative c, you are going to get 2 solutions, always. I guess we should write down the answer here. Oh, I did. 2 solutions. B squared minus 4ac. That's all we have to do. Well, how many of you can tell right away it's going to be a negative number before you actually calculate it? Because it's going to be 1 squared, negative 1 squared minus a big number. Negative 263. No solutions. So, this is the discriminant. The discriminant of a quadratic equation is the value of b squared minus 4ac. If that thing is greater than 0, now we got to go through this language. I wish we didn't have to, but we do. If it's greater than 0, then what we say in math, what the math people say, is the solutions are real. They're real numbers. And they're unique, which means they're different. They're not identical. So what does this mean to us? What it means is this. There's 2 different solutions if the discriminant is greater than 0. If the discriminant is less than 0, here's what the math people say. The 2 solutions are not real. What do we say? There are no solutions. If the discriminant is equal to 0, we say the solutions are real, and there's two solutions, but they're the same solution. Math people are weird. The two numbers are the same, but there's two of them, so there's two solutions. No, there's one solution. So we don't have to worry about real and unique or real and equal or things like that. So if the discriminant is greater than 0, that's what the graph would look like, two solutions. If the discriminant is equal to 0, this is what the graph might look like. And if the discriminant is less than 0, this is what the graph might look like. Before we finish this off today, does anybody have any questions so far with this? Okay, so I'm going to give everybody about 2 minutes here. You're going to write 0, 1, or 2 for the number of solutions for each of these 4. With question B, you have to do just a moderate amount of work by zeroing the equation first. And with question D, there is no B, but there's always a B, so we can write B equals 0. I think those discriminants are right, aren't they? What I get is 2 solutions, 0 solutions, 1 solution, 0 solutions. Are we on the same page there with this? Perfect. Now things take a little bit of a turn. You've got a quadratic equation that's 16x squared plus kx plus 81. And you're told this is equal to 0. You're told there's only one solution. What's the value of k? So what we could do, everybody, is first of all, if there's one solution, that tells you that b squared minus 4ac must be equal to 0. And again, I'll be honest with you, I don't memorize that. In the time, when I'm writing that and speaking out loud, I'm in my head doing a third thing, which is confusing sometimes for me. And that's to say, how do you get one solution out of the quadratic formula? And the answer is if you're going plus or minus nothing. So that process is going on in my head. So what you could do is you could guess. You could say, well, you know what? Maybe k is 5. And you could put 5 there and calculate the discriminant and see if you get 0. But that's not a very efficient way of doing it. So what you can do instead is this. you can set the discriminant equal to 0, put k in for b, put in the value of a and c, and solve that equation. Algebra is a very powerful tool here. So I end up with k squared equals whatever 64 times 81 is. $51.84. So now we take the square root of that. And by the way, the square root of that is a perfect square. That gives you 72. If I were your student and you were my teacher and I put this, would you give me full marks? What's wrong with it? It isn't that you're not showing enough work. That's not it. Don't know? Plus or minus. And you can check this out. If I put negative 72 here and you calculate the discriminant, you'll get 0. If I put positive 72 here, you'll get 0. Let's try one more. A quadratic equation is given by kx squared minus 5x plus 5. Equals 0. One solution. What is the value of k? Well, this is the same as question 2. It really is. B squared minus 4ac has to give you 0. Why 0? Does it have to give me 0 because there's a 0 up here in the equation? No. It has to give me 0 because there's one solution. You can solve this. You better be able to solve this. Simplify it first and get 25 minus 20k equals 0. Move the 20k over and divide by 20. So, oops. So x is not the variable we're after. K, on the other hand, is 5/4. You still with me? Okay, now the rest of this is not that difficult, but there's a little bump in the road that most people are either not aware of it existing or they drive over it without looking. There's something here that in the next part that people make a mistake. What if that same equation, kx squared minus 5x plus 5 equals 0, what if that same equation had no solutions? What is the value of k now? Well, b squared minus 4 times a times c has to be negative, has to be less than 0. Right? And we need to solve that for k. Well, you know, at first glance, we get the exact same thing, don't we? We got 25 minus 20k before on the left, because it was the same equation, but this time it's less than 0. So now, and this is important enough to spend a few extra minutes on. There are two schools of thought here. One of them is this, and it's what I do. I take that 20K and move it over and get 25 is less than 20K. So I divide both sides by 20 and I get 5 over 4 is less than K. All right? The other school of thought is to take that 25 minus 20K equals 0, subtract the 25 from both sides, and divide both sides by negative 20 and get K, whoops, it's not equals, it's less than. Sorry. And get K is less than 5 over 4. Okay? Now, if you've been writing that down, you're going to have to erase some of it because some of it's wrong. Okay. The first thing I want to talk about is what does this mean here? What it means is K is greater than 5/4. And I'd like you to think about that for a second. If I say 5/4 is less than K, what's K? K must be greater than 5/4. The analogy that I use usually with this is if I had I instead of K and 8 instead of 5/4, if I had that statement there, and I read it backwards, I read it as I first, then I have to reflect this, and that's what it looks like. Do you agree that says I is greater than 8? So if 8 is less than I is greater than 8. So the answer to this question is right here. Why is this wrong? This is the little bump in the road that many of you were taught this, but you use it so rarely, you forget about it. Does anybody know what I've done wrong in solving that inequality? Sasha? Right. Excellent. Whenever you divide or multiply by a negative and there's an inequality involved, you have to flip the inequality over. So if I divide an inequality that says less than by a negative, I have to reflect that inequality to turn it into greater than. And now you can see that that's the correct answer. Just by a show of hands, how many of you would just prefer to do it this way and read it backwards? That's what I would actually recommend. But if you're fine with the rule of flipping the sign, that's okay too. Let's take a look at the final question. First of all, I want to point out to you that if you had a number line for K, we have already decided that when K is 5/4, there's one solution. Can you just double check that that's what we had for part A of the question? That if K was 5/4, we had one solution. We have just discovered, I'll go back and look, that if K is greater than 5/4, there are 0 solutions. Would you agree? Do you also agree that a quadratic equation must have either none, 1, or 2 solutions? Has to? You can't have 3 solutions. You can't have negative solutions, negative number of solutions. What that must tell you, everybody, is that if K is less than 5/4, there must be 2 solutions. Do you kind of get that weird graph I've just shown you here? The green part is 0 solutions. The red part is no solutions. The black part is two solutions, and it covers every possible value of k. So let's solve this one and just confirm that we're going to get two solutions that's indicated in black. B squared minus 4ac, that's negative 5 minus 4 times k times 5 must be, if there's two solutions, greater than 0. Which means, forgot to square my negative 5, 25 minus 20k must be greater than 0, which means 25 has to be greater than 20k. If we divide both sides by 20, that means 5 quarters must be greater than k, which means k must be less than 5 quarters. Okey smoky, look at that. That's what we used logic to figure out in terms of an answer. Any questions with that final example? All right. So you've got a fair amount of time today here, about 25 minutes or so, 25, 30 minutes. That assignment is due tomorrow. I'm dealing with some things right now. I'm not whining, but I'm just saying I'm going to change the due date to Wednesday because I'm probably not going to have time over the next couple of days to mark it anyway. So there's a problem here for you. And that's that if I take it in Wednesday, you're not going to get it back before you write your exam. So if you're fine with that, that's fine. If you need it back before the final exam, then give it to me tomorrow and I will find time to mark it. It's no problem. I will do it. But I'm saying if you need an extra day, take the extra day. Okay? Page 254, 1, 2, and 5 should match what's in your handout. Here's kind of a summary. I'll just leave this up here for you to peruse. It demonstrates what I've told you in print about the three cases. So get to work. I want to do something quickly at my computer and then I'll come around and give you a hand.